Hi everyone, it's Miss Costa, and in this video I'm going to be going through all of the algebra topics that you need to know in order to secure a grade 6 in the exam. Now in the top right hand corner I write the topic name and also the rough grade that it is, and try not to ignore topics that might be a grade 3 or 4 or 5 just because you're like, oh well, I'm aiming for a 6, I don't need to know this. You need to, in order to get the 6, you need to be able to do all of the topics, and sometimes it's the easier topics that actually let us down. So have a go through all of them. Okay, so to start with, we are given a fraction and we are asked to simplify it. Now, this is just an extension of index laws. And what I can do is, there's quite a few ways I can do this, but if you get super stuck in the exam, then just think to yourself, okay, I'm just going to take it back to basics. And what does it actually mean? Well, that means 24 times by x times by x times by x, because the little power tells you how many times x is multiplied by itself, times by y times by y, and then 8 times by x times by x times by y. So you've just brought the algebra back to its simplest terms. And when we have fractions, if the numerator and the denominator are just a product, so everything is being multiplied, then anything that is divided by itself can be cancelled, because like 5 divided by 5 gives me 1, so therefore y over y is also going to be 1. So I've got x divided by x, which would cancel, x divided by x, which would cancel, and here y divided by y, which would also cancel. So I'd then be left with 24y over 8. And you could also have done this just by using the laws of division, by subtracting the powers. So 3 take 2 is 1, 2 take 1 is also 1. So actually there should be a y on the top, yeah. So I've got 24y divided by 8. Now another way, I could just divide that, or I could write it down into its basic factors. So I want to think to myself, does 8 fit into 24? Yep, so that would be 8 times by 3 times by y divided by 8. And then the 8 and the 8 would cancel, and you'd just be left with 3y. So a few ways to do this, but as always, if you get super stuck, just take it back to the basics and see what you can do with from there. Okay, now the difference of two squares comes up a lot, so it's important that we know it. And all it's essentially saying is that if you've got x squared or y squared or anything, take away a square number, then when you factorise it, it's always going to be x plus the square root of the number, and then x minus the square root of the number. And the reason for this is, if you had, let's just show it in its inverse, x plus 4, and then x take 4, and you expanded that, you'd get x squared minus 4x plus 4x, and then take 16. So because one of the brackets has a positive and one has a negative, you're always going to get these two middle terms that collect and cancel, and a positive times a negative always gives you a negative product. So that's why you always end up with x squared take away the square number. So if you notice x squared take away a square number, to factorize it, you just put it as x plus the square root of that number, x minus the square root of the number. So we've got a slightly harder one here. So we've got 9x squared, 9 is a square number and x squared is a square number. So I'd square root that as 3x. And then the square root of 16 is 14. So that would be 4y. And then 3x plus 4y. And so if you're ever not sure if you've done it right, just double check by expanding the brackets, as factorising is the inverse of expanding brackets. So that would give me 9x squared minus 12xy. Well, in this case, it would be plus first, and then minus 12xy, and then minus 16y squared. So we see that the two middle terms collect, they cancel each other out, and I'm just left with 9x squared minus 16y squared. Okay, so the key is you're just looking for a square number minus another square number. And for this last one, it's just a little bit trickier because 3 is not technically a square number, but however, I could write it in its third form. So if it's asking you to factorise something like this, it's a bit sneaky, but all we do is we do x plus the square root of 3 and x minus the square root of 3. And you can always double check this, because x times x is x squared. Then x times negative root 3 would be negative root 3x plus root 3x. And then minus 3, because a third multiplied by itself is its unsurd self. Like if we had square root of 25, we know that the square root of 25 is 5, and 5 times 5 makes 25. So it's always helpful to remember that, but this one's trickier because it's involving surds, but it's the same principle, and just double check it and you'll see that it works. Okay, so here I'm being asked to simplify an algebraic question, and the key with questions like this is that you're always going to try and start by factorising the numerator and the denominator, and you're ideally looking for a factor that is common to both. So x squared take away 9, that's the difference of two squares, so I'm going to say x plus 3, x minus 3. And then my bottom bracket, when I'm factorising, I'm looking for factors of the last number. So every quadratic is written ax squared plus bx plus c. So you're looking for two numbers that multiply to make c, and then add or subtract to make b. So in this case, factors of 12, and they add together to make 7. So I could say 3 times 4, 2 times 6, 1 times 12. And in this case, it's a nice and simple one. 3 times 4 makes 12, and 3 plus 4 also makes 12. So I can factorise it like that. Once you have factorised it, then hopefully one of the brackets on the numerator and one on the denominator are going to be equal. So because this is all a product, when I'm expanding brackets, it means I'm multiplying them. So I could cancel x plus 3, and I'd be left with x minus 3 over x plus 4. So whenever you see an algebraic fraction, you're being asked to simplify, the first thing you need to think to yourself is factorize it. Okay, so here you've got a proof question, and literally when you see something like this is just, you should be like, wow, 3 marks, because all you have to do is expand both sides and simplify them and show that they simplify to the same thing. So let's start with expanding x plus 5. X times x is x squared. X times 5 is 5x. 5 times x is 5x. And 5 times 5 is 25. And then I'm going to subtract from this, and be very careful with this because this is what catches so many people out. I'm going to subtract x plus 2 squared from it. So x times x is x squared. X times 2 is 2x, 2 times x is 2x, and 2 times 2 is 4. So I can simplify this to become x squared plus 4x plus 4. And I am subtracting this, and let's just simplify this as well. So it's important to bear that in mind. So either keep that really ahead in the forefront of your mind, you know you're subtracting, so you know you're going to be minusing x squared and then minusing this and then minusing that. Or if you know you get confused with these, just imagine this is a bracket and there's a -1 in front of it, and then expand it. So that would be minus x squared minus 4x minus 4. So this is the part that people just get a bit stumble at and then just use the wrong signs by accident. So if you know that's going to be you, put it in a bracket, put a -1 in front of it and expand the bracket first. So we have this whole expression subtracting this expression. So now let's collect the terms. X squared minus x squared is going to cancel out. 10x minus 4x is 6x, and 25 minus 4 is 21. So we can say 6x plus 21, and this is just an identity sign. It just means that both sides of the equation are absolutely equal, just expressed in different ways. So we know this because I can then expand that out, and what does it become? Well, that becomes 6x plus 21. So that's how you've proved it, literally just by showing step by step how you expand one, simplify it, and then it becomes equal to the other side of the identity. Okay, so here's a show that question, and with any show that question, you want to show each step of your working. So I'm told the diagram shows a shape with all its measurements in centimetres, and I know that the area of the shape is a centimetre squared. Show that a is equal to 2x squared plus 20x plus 14. So let's think, how am I actually going to work out the area of the shape? It's a compound shape, which means it's made up of two shapes, and I can split it into two rectangles. So there's a few ways I can do this. Either I could split it like this, or I could split it like this. So I think I'm going to go with splitting it this way. So let's think, this part, this rectangle here, I know this length is 3 and that length is x plus 2. So I know the area of this is going to be 3 brackets x plus 2, which is 3x plus 6. So that's one part of the area. Then I need to work out the area of this rectangle here. Now, once again, be very careful. You know that this length here is 3. So 3 plus something must equal 2x plus 4. Therefore, 2x plus 4 minus 3 must be this missing length here. So that means that that length is 2x plus 1. So to work out this area here, we have a length of 2x plus 1 and x plus 8 over here. So I just multiply those two to figure out the area. So if I expand that, that becomes 2x squared plus 16x plus x plus 8. And I could simplify that to 2x squared plus 17x plus 8. So I've got my two parts of the area. So this is 2x squared plus 17x plus 8, and this one there is 3x plus 6. So now let's bring them together. Add them together would become 2x squared plus 20x, and then 8 plus 6 is 14. Now I just ran out of a bit of space, but you might just want to say, because it's a show that question, you would just add them together. And that's how we show that the area equals what the question told me it does. Okay, so with algebraic proof, there are just a few key things we need to know. So if I called absolutely any number n, I don't know if it's odd or even, but whatever the number is, if I multiply anything by 2, it must be an even number, because just think 3 times 2 is 6, 4 times 2 is 8. Anything multiplied by 2 is an even number. So therefore my expression for an even number is 2n. Similarly, if I know that any number is even, in order to make it odd, I either add 1 or subtract 1 from an even number. So therefore saying 2n plus 1 or 2n minus 1 is an expression that I use for an odd number. Sum just means addition, and a multiple of anything, if you can factorize it and get it in the form where the multiple is on the outside of the bracket, you prove that it's a multiple of it. So in this question, I'm being asked to prove algebraically that the sum of any 3 odd numbers is not a multiple of 2. So start with an expression for an odd number. I'm going to start with 2n plus 1. Now, this is where it gets a little bit confusing. So if this was my odd number, 2n plus 1, the next number would be 2n plus 2. But because when you have numbers, you have odd number, then you have even number, then odd, then even, and so forth. The next odd number would actually be 2n plus 3. Now this question hasn't said consecutive odd numbers, so I could have just written any odd number, but I'm going to just do it as though it did say consecutive odd numbers. So the next odd number would be 2n plus 3, and the one after that would be 2n plus 5. And the reason for that is because every number in between them would be an even number. So to ensure that it's an odd number, I do 2n, which makes it even, and then plus an odd number. So sum means add. So let's add all these together. 2n plus 1 plus 2n plus 3 plus 2n plus 5. 2n plus 2n plus 2n is 6n, and then 1 plus 3 plus 5 is 9. So I need to prove algebraically that the sum of any 3 odd numbers is not a multiple of 2. So I need to prove that it cannot factorise down to 2. So if I factorise it fully, 3 is the highest common factor. So that would be 3 brackets 2n plus 3. Now, this proves that it's an odd number because 2n makes it even, and add any odd number, it keeps it odd. And 3 times by an odd number, so 3 times any odd number is odd. Therefore, it cannot be a multiple of 2. So you've taken it down to its most basic form, and you've shown that you can't factorise it any further. The smallest factor is 3. Okay, so I'm using algebraic proof and sequences this time in order to prove something. So the nth term of a sequence is given by the expression 2n minus 7. So the nth term is 2n minus 7, and the sum of 2 consecutive terms is 188. Now, this is a really key piece of information. Consecutive means they have to be one after the other. So if the first number in the sequence that I'm trying to find is n, the number after it is going to be n plus 1. So I know that 2n take 7 plus 2 lots of n plus 1 take 7 must equal 188. And I think this is where a lot of people maybe get a bit confused, because they might have just done 2n take 7 plus 2n take 7, but that's the nth term. And if you know that you found the value of one term, n, the next consecutive term must be n plus 1. So let's just expand and simplify. That would give me 2n take 7 plus 2n plus 2 take 7 must equal 188. So 2n plus 2n is 4n, minus 7 is minus 14, plus 2 is minus 12, equals 188. So then add 12 to both sides. 4n is going to equal 200, and divide by 4, n is going to equal 50. So that means that n is 50, so it's the 50th term, and therefore the two terms are the 50th term and the 51st term, and I need to work out the value of n. So if n is 50, 2n take 7 is going to be 2 times 50 take 7, which is 100 take 7, which is 93, and then the consecutive term is going to be 2 times 51 take 7, so that's going to be 102 take away 7, which is 95. And double check, does 93 plus 95 give you what we want? 3 plus 5 is 8, 9 plus 9 is 18. Okay, so it's a little bit of an unusual one, but it's about recognizing how we can write consecutive terms. Okay, so this is another really common misconception. People always forget this. Whenever you've got numbers in brackets, remember that each little part inside is being multiplied to the power of 3. So if this is something that confuses you and tricks you and catches you out each time, just actually write it out as what its pure algebra means. So I know that cubed means the whole thing is being multiplied by itself 3 times. So I could just write it out like this to remind myself that everything is being multiplied 3 times. That would then be like, oh, okay, so I've got 3 is being multiplied by itself 3 times. So that'll be 3 cubed, which is 27. X squared times by x squared times by x squared, using the laws of indices. Remember, when you're multiplying powers, you just add them. So that would become x to the power of 6, and then y cubed. And once again, if even this is a bit of a stretch, just simplify it even further. So you ended up with this, and then you would realize why it simplifies to what it does. But the key thing is that don't let the bracket trip you out. It's each individual part that is being done to the power of 3. Okay, so we've been given a sequence and we're being asked to find the nth term. Now the nth term is literally just the rule to find any term in the sequence. So we start by just figuring out what times tables the sequence goes up in. So how do I get from 4 to 9? I add 5. 9 to 14, I add 5, and so forth. So that must mean that my sequence is going up in the 5 times tables. So whatever times tables your sequence is going up in, that's what is going to be the coefficient of n. And then what you could do is just write out the first few terms of the 5 times tables above your sequence. And you could be like, okay, so it's the 5 times tables, but it's not exactly, it's been shifted. So it's the 5 times tables, but each term is actually 1 less than my 5 times tables. So you think, how do you get from the 5 times tables to this sequence? Well, each term, how do you get from 5 to 4? You take 1. How do you get from 25 to 24? You take 1. So therefore, the n term is 5n take away 1. Now, sometimes you might be asked, you'd be given the nth term and you're asked if a term is in the sequence. So what we do is we just equate the nth term with that number, and then we can solve it. And if we have a integer, a whole number, then it's a term, and the solution tells me what position in the sequence it's in, and if not, then it's not. So if I add 1 to both sides, I'd be left with 5n equals 201, and then I'd need to divide both sides by 5. So n would be, and if it's non-calculator paper, just use the bus stop method, but well, you know already it's not going to be an integer, but just to prove it, 5s into 2 don't go, so 5s into 20 go 4, 5s into 1 don't go, so we just put a bunch of zeros, and there's a remainder of 1, and 5s into 10 go 2. So that would be 40.2. So you would say no, it does not, as if it did, it would be the 40.2 term, which doesn't exist. So in sequences, you don't have decimal terms. Like you don't say, oh, that person finished 4.2. You just say 4th, 5th, 6th. Everything is in whole numbers. Similarly, sometimes you might be given the nth term and asked to write out the first 5 terms. So the first 5 terms of any sequence. Now n, that just represents the position. Okay, so whether it's the first, second, third. So for the first term in any sequence, n is going to be 1. So I'd do 3 times 1, take 4. So 3 times 1 is 3, take 4 is minus 1. Then I'd do, n would be 2. So I do 3 times 2, take 4. 3 times 2 is 6, take 4 is 2. Then I do 3 times 3, which is 9, take 4 is 5. 4 times 4, 3 times 4, which is 12, take 4, which is 8. And now you should see that hopefully it's going up in a nice sequence. So you know that it's going up in 3s, because it's going up in the 3 times tables, and it's always 4 less than that term. So once you've got to a few of the terms, you could just add it on. But it's better to be safe and just figure out 5 times 3 is 9, 5 times 3 is 15, take 4 is 11. Now, what is the 30th term in the sequence? Remember, n is the position in the sequence. So the 30th term, all I'm going to do is substitute n equals 30 into the nth term. So I'm going to say 3 times by 30, 3 times by n, take 4. So that's 90, take 4, which is 86. So the 30th term is 86. Okay, so here I've got some simultaneous equations. Now the key with simultaneous equations is that you want to identify one of the variables, and ideally one of them is going to be equal. So this is a nice and easy simultaneous equation to start us off with. I can see that the y variables are equal, and what I want to do is eliminate them. So in order to eliminate, I need to think to myself, okay, 2 something 2 must equal 0, and in this case positive 2 take 2 is going to equal 0. So that tells me whether I need to add or subtract my equations. In this case, I'm subtracting them. So 4x take away x gives me 3x. 2y take 2y cancels. That's why I do it. And 10 take away 7 is 3. So I know that 3x equals 3. I then just solve the equation in order to find the value of x. And in this case, x has a value of 1. So when I have solved it for x, what I do is I then substitute that back into one of the equations. So when x is 1, 1 plus 2y must equal 7. I've just substituted x equals 1 into this equation. It's always better to do it into the easier one, but it doesn't matter, you get the same value for either. So if I subtract 1 from both sides of the equation, I'm left with 2y equals 6, and then I just divide by 2, so y equals 3. Okay, so with simultaneous equations, you're always going to get two answers, the x variable and the y variable. So you'd say x is 1 and y equals 3. Okay, so here I've got some slightly trickier simultaneous equations. So remember, the key thing is you want one equal variable. Okay, that's what you are ultimately aiming for. So here we've got both of our variables are different numbers, and by variable I just mean x or y. So just choose which one you want to manipulate. I'm going to start with the x's just because I feel like it. So in order to do that, I want them to be equal. So you find the lowest common multiple and then you multiply them across. So the lowest common multiple in this case is going to be 6x. So I'd have to multiply this whole equation by 2 in order to get this to 6x and this whole equation by 3. So let's just do that step by step. 3x times 2 is 6x. 2y times 2 is going to be 4y. And 2 times 7 is going to be 14. Similarly, with the equation underneath, 3 times 2x is 6x, 3 times 9y is going to give me 27y, and 3 times by 43 is going to be 129. So now I've got simultaneous equations where I have one equal variable. And again, I have to decide whether I'm going to add or subtract them. Now I'm just going to change their position because this is a larger number. So I'm just going to write them as 6x plus 27y equals 129 and 6x plus 4y equals 14. I've just switched their position. You're allowed to do that. A lot of people think you're not, but you are. And now I just want to think, okay, what do I need to do in order to eliminate my x variable? So 6x plus or minus 6x must equal 0. Well, in this case, it's another subtraction. So 6 take away 6 cancels out. And then I subtract everything else. If this happened to be a negative 6x, then you'd have to add. Okay, and then everything in the equation you would also add. But in this case, it's not. So I'm just going to subtract. So 27 take away 4 leaves me with 23y, and 129 take away 14 leaves me with 115. So I know that 23y is 115. So I need to do 115 divided by 23. And that would give me 5. So if I divided both sides by 23, that gives me 5. If you got stuck in this as a non-calculator paper, just write it like that and then see what you could divide each part of the equation by. So I know that y equals 5. And if y is 5, then I just substitute it into one of the equations. The easiest one is going to be the first one. So I know that 3x plus 10, because if y is 5, 2y is going to be 10, must equal 7. I solve it in order to find the value of x. So I take 10 from both sides. So 3x is going to be 7 takes 10 is negative 3. And therefore x equals negative 1. So my final answer is going to be y equals 5 and x equals negative 1. Okay, so evaluating functions is actually very simple. So if you see this, even if it's one of the last questions on the paper, if it just says find f of 5 or g of minus 7 or whatever, all you're doing is you're substituting that value into the function. So given that f of x is 2x plus 5, find f of 5. So all I'm doing is wherever I see an x, I replace that and I substitute it with a 5. So that would be 2 times 5 plus 5, because 2x means 2 times by x. So what you could do is write your function into its purest algebra form and then simplify like that. So 2 times 5 is 10, and then 10 plus 5 is 15. Okay, for the next one, I need to find f of negative 3. So once again, wherever I see an x, I'm going to substitute negative 3. 2 times negative 3 is negative 6, and negative 6 plus 5 is negative 1. Now for the last part, it's a little bit trickier. I'm asked to solve f of x equals 10. So essentially what that means is I want to make this equal to 10. So I'm just going to say 2x plus 5 equals 10, and then I can solve it in order to find the value of x. So I take 5 from both sides, and 2x must equal 5. I then divide by 2, therefore x must equal 2.5. Okay, so in these equations I am changing the subject, and all that means is that I am moving things from one side of the other until I get it in the form, in this case, y equals. So when it says make something the subject, it means get that variable on its own with an equal sign. And I want to do things step by step. So if you get a little bit confused by what's happening with the algebra, just draw yourself a function machine. So starting with y, what is happening to y? I'm adding 2 to it, and then I'm dividing by 5. And what comes out is x. So what I want to do is the inverse of that. So the inverse of dividing by 5 is timesing by 5. The inverse of plus 2 is minus 2. So I'm going to need to do x times by 5, take away 2, and that is going to give me my inverse. So let's start by doing that. I know that the first step is to times both sides by 5. So x equals y plus 2, 5x equals y plus 2. And the next step would be to subtract 2. So 5x take 2 equals y. Now you could do it like that, or you could have done it from the function machine, because you know that x is being times by 5, and then take 2, and that gives you y. So whichever way works best for you. And generally when we make something a subject, we just want to make it so that it's y on this side. It doesn't really matter, they're both the same, but it's just nicer to have the subject on its own on the left hand side. Now we've got another fractional equation here, and so this is why it's helpful to draw a little flow chart. So what is happening in order to get y, we're starting with x this time. So what's the first thing that's happening to x? Well, firstly, it's being divided by 4, and then I am subtracting 7. And what comes out is y. So I need to do the inverse of that. So I'm going to have to add 7 first, and then times by 4. So this is helpful if you get confused as to why aren't you timesing by 4 first. If I times by 4, whatever you do to one part of the equation, you have to do to each part of the equation. So that's why we save the timesing till the last bit, because then you've only got one term on that side. Otherwise you'd have to get 4y equals x take 28, which is fine, you can do that, but just people forget that you need to multiply each little part. So let's have a go at doing this. The first step is going to be add 7 to both sides. So y plus 7 equals x over 4. And then I'm just left with one term, and that's why I multiply. So I multiply both sides by 4, and I'm left with 4 brackets y plus 7 equals x. So I could expand it if I wanted to, or I could leave it in factorised form. So x is just 4y plus 28. So this one's a little bit trickier. It's going to involve a little bit more manipulation, like factorising and then expanding, but let's have a look. So whenever you've got a denominator, generally you're going to want to multiply both sides by the denominator just so that it's no longer in a fraction. So if I times both sides by x minus 2, then I'm no longer left with a fraction. So y brackets x minus 2 equals x plus 3. Now I'm trying to make x the subject, so I know that my end game is to get it in the form x equals, but I'm going to have to do a little bit of manipulation in order to do that. I'm going to expand the brackets, so I'll be left with xy minus 2y equals x plus 3. And then what I can do, because I've got x on both sides of the equation, I can move it so that x's are all on one side and any other terms are on the other side. So I could say xy take x, because I've taken x from both sides, must equal, and then I add 2y to both sides, 2y plus 3, or 3 plus 2y, it doesn't matter because they're being added. And then what I do is I factorise, because I've got two terms that have x in them. So if that ever happens, just factorise it so you can bring it to 1. So factorise it to take the x out. That would become xy take away 1 equals 2y plus 3. And then you've just got one little x term. So you just want to divide both terms, both sides, by whatever is being attached to it. So x is going to equal 2y plus 3 over y plus 1. So it looks complicated, but all you have to do, if you've got something complicated like this, just expand it, factorise it, expand it again, move it, jiggle it around, and you get x on its own. You can do as much manipulation as you want. So even if something goes wrong, just keep doing things and eventually you'll get there. Okay, so some solving of linear equations. These are a little bit trickier because they've got brackets. So let's have a look at what's going on. So 7x take away 2 must be equal to 3x plus 15. Now I've got x on both sides of the equation. So what I want to do is subtract the smaller value of x. So I'm going to take 3x from both sides of the equation. So I'm left with 4x take 2 must equal 15. Then I can add 2 to both sides of the equation. So 4x is 17. And the last step, I know x is being times by 4, so I'm going to have to divide by 4. So I can say x is 17 over 4. Now, because this is, if this is a non-calculator paper, it's absolutely fine to leave it as 17 over 4 unless they specifically ask for the value, in which case you just be like, okay, fine, I'll use the bus stop method. 4 is into 17, go 4, remainder 1. 4 is into 10, go twice, remainder 2. And then 4 is into 20, go 5. So you'd say x is 4.25. Now for the next question, you've got slightly trickier one. What do we do whenever we've got a fraction? We want to just multiply both sides by the denominator. So let's do that. So we'd be left with 4 brackets 3x plus 2 must be equal to 2x plus 1. I can expand the bracket, so then 12x plus 8 must be equal to 2x plus 1. And then I just manipulate the terms. So I've got x on both sides, so I want to subtract the smaller x. So I'd be left with 10x plus 8 must be equal to 1. Then I can take 8 from both sides. So 10x is equal to 1 take away 8 is negative 7. And therefore x must be minus 7 over 10, which you could leave as a fraction or a decimal. Okay, so in this kind of question, I have been given some information and told the values of some of that information, but not other parts of that information. So when you've got a question like this, if you get stuck and you have an unknown value, then just use algebra. Okay, let algebra help you out and then see if that makes any difference. So I know that Valentina is 5 years older than Jasmine. So what I could do is, I don't know how old Jasmine is, so I can just call her age X. I know that Valentina is 5 years older than her, so I could write that as X plus 5, because however old Jasmine is, Valentina is 5 years older than that. Then told that Layla is 3 times as old, so whatever Valentina is, times by 3. And whenever we're forming an expression with algebra, if there's more than one term that is being multiplied, we put it in brackets. So we'd say that would be 3 lots of x plus 5. And I know that the sum of their 3 ages is 95. So these 3 expressions added together is going to give me 95. So Jasmine's age, which is x, plus Valentina's age, which is x plus 5, plus Layla's age, which is 3x plus 5, must equal 95. Now I could just expand this quickly, so that would be 3x plus 15. And then I could simplify. So let's bring all the letters together. X plus 3x is 5x. And 15 plus 5 is 20. So 5x plus 20 is 95. So if I know that 5x plus 20 is 95, I could subtract 20 from both sides. And then I'd be left with 5x is 75. 5 times x means x is being multiplied by 5, so the inverse is dividing by 5. And 75 divided by 5, if it was non-calculator, just plug your 5 in. 5s into 7 go once, remainder 2, 5s into 25 go 5. So x would be 15. Now I'm told to find the ratio of Jasmine's age to Layla's age. So Jasmine would be 15 because her age is just x, and Layla's age would be 3 times by 15 plus 5, so 3 times by 20, which is 60. So the ratio would be 15 to 60. It hasn't actually asked me to simplify it. If it had, then you'd just divide by, well, initially you could divide by 5. So that would be 3 to 12, because I've divided both sides by 5, and then I could divide by 3. So that would be 1 to 4. But it hasn't asked me to do that, so leaving it in the ratio 15 to 60 is absolutely fine. Okay, so another forming and solving equations. I'm told that Joshua has 3 shelves on his bookcase. There are X books on shelf 1. So shelf 1 has X. There are 3 more books on shelf 2 than there are on shelf 1. So if shelf 1 is X, then shelf 2 must be X plus 3. And then there are 2X minus 6 books on shelf 3. So in this question, they've actually given us some of the expressions. Now, I'm told that there is a total of 45 books on his bookcase. So I know that this, shelf 1, plus this must equal 45. So I can form that equation, x plus 3 plus 2x minus 6. And remember, some people, for some reason, they're like, oh, I wrote x once, so I don't need to write it again. No, each time you need to write out the full expression. So that must equal 45. And then you simplify it. So x plus 2x is going to give you 4x, and 3 take away 6 is minus 3. So 4x minus 3 is 45. If you add 3 to both sides, you're left with 4x equals 48. And then we divide by 4. So therefore x equals 12. Okay, so I know that on shelf 1, there are 12 books. There are 15 here. And there are 30 take away 6 is 24. So all of the books have the same mass. Okay, well, they must be from the same publisher then or something, because that's very hard to achieve. But hey, the books on shelf 2 have a total mass of 8,250 grams. So I know that 15 books is 8,250 grams. Work out the total mass of the books on shelf 1. Well, there's a few ways that I can do this. What I'm going to do is, how can I get from 15 to 12? Well, if I divide by 3, if this is a non-calculator paper, if it's calculator, just divide by 15 and times by 12. But non-calculator method would be if I divide by 5, then I'd be left with 3 books must equal, and let's just quickly do our division. So 8,250 divided by 5. 5s into 8 go once, remainder 2. 5s into 32 go 6, remainder 2. 5s into 25 go 5. And 5s into 0 is 0. So 3 books must be 1,650 grams. And how can I get from 3 books to 12 books? Well, I can multiply it by 4. So just a little trick that you can use if it's calculator paper. So 1,650 times by 4 is the same as timesing it by 2 and then timesing it by 2 again. Or it might just be easier to just times it by 4. So 4 times 0 is 0, 4 times 5 is 20, 4 times 6 is 24, plus the 2 is 26, and 4 times 1 is 4, plus the 2 is 6. So 12 books are going to be 6,600 grams. And that's how you do that question. So form and solve your equations and then use the information to figure it out. Again, you could have done this a lot simpler if it was a calculator paper. You could have divided it by 15 to find out what the mass of one book was, and then times by 12. Okay, so here I've been given 2 rectangles, A and B. And I'm told that the area of rectangle X is equal to the area of rectangle Y. So this is important because I can form 2 equations and equate them. So how do I work out the area of a rectangle? I do length times by width. So I know that 8 times by 3a plus b must be equal to 4a times by 2b plus 9. So this is quite a complicated little thing that I've got here, but let's just go with it and expand it. So 8 times 3a is 24a, 8 times b is 8b. That must be equal to 4 times 2 is 8ab plus 36a. So now I know that these two sides must be equal. What I can do is rearrange it so that I've got a on one side and b on the other side, collect the like terms. So I could start by just subtracting 24a from both sides because I've got a on both sides. So that would leave me with 8b equals 8ab plus 12a. Okay, so now that I've expanded it, I want to look back and find out what the question is actually asking me to do. So it's saying find an expression for b in terms of a. So I'm trying to find an expression for b in terms of a, which means all of the a's are going to be on this side, but b is the subject of my formula and the terms are on the other side. So I want to isolate all of the b variables and put them together. So I could say 8b, take 8ab equals 12a. I could then factorize to pull out the b term. So whenever you've got two terms that have the same variable, but you can't collect the like terms, you can factorize it. So I pull out the b, and that would be 8 take away 8a equals 12a. And then I want to just get it in the form b equals. So I divide both sides by this bracket because it's being multiplied currently. So that would be 12a over 8 take away 8a. It's not asking me to simplify it, so I don't need to worry about that. So b is 12a over 8 take away 8a. Okay, so the key thing to remember with solving quadratics is A, you need to get them so that they are in the form ax squared plus bx plus c equals 0. Okay, so they need to be in that form in order for you to then be able to factorize and solve. So step 1, rearrange it so that all the terms are on one side and they're equal to 0. So we could start by taking 2x. So that would give me x squared, take 2x equals 48. And then you just take 48 as well. So you'd be left with x squared, take 2x, take 48 equals 0. Now, once it's equal to 0, step 2 is to just factorize it. Okay, so when we factorize, we're trying to find the factors of negative 48. So 1 times 48, 2 times 24. There's lots of factors of this one. And we're trying to find the two factors that multiply to make negative 48. So I know one is going to be positive and one is going to be negative, and they add or subtract to make minus 2. So let's continue on with our factors. 48 divided by 3 is 16, so it could be 3 times 16. But I know that the numbers are going to be fairly close together because when you subtract them or add them, you get minus 2. So 48 divided by 4 is 12. 48 divided by 5 doesn't work. 48 divided by 6 is 8. And then you'd get 7, which doesn't work, and then you'd get 8. So you know you've got all the factors because as soon as a number on this side is equal to a number on that side, you know you've done all your factors. So out of these factors, which can I add and subtract in order to make negative 48? All of them, and rearrange to make negative 2. Well, if I had 6 take away 8, that gives me negative 2. So whenever this number is like a small number, you know that the numbers must be quite close together. So I know that in my brackets, I'm going to have x plus 6 and x take 8 must equal 0. Because remember, I said 6 times 8, and then how did I do it? 6 take away 8 equals minus 2. If it was 8 take away 6, it would be positive 2, and that wouldn't work for that quadratic. Now, when you're solving a quadratic, what you do, the final step, is you literally just write your solutions, your x values are going to be the inverse of what it is over here. So you'd say that x is -6 and x is +8. So you just reverse the signs. I'm just really quickly going to explain to you why, because otherwise you might just be like, why am I learning this? So what am I doing? If I've got x + 6 times by x take away 8 equals 0, let's just equate it to something slightly easier. If you had 3x equals 0, what are you doing first of all in order to find the value of x? You are dividing by 3, okay? So if you divide both sides by 3, you know that x would be 0 because 0 divided by anything is 3. And that's because there's a little multiplication sign in between the 3 and the x. And it's the exact same thing when you're multiplying brackets. They're being multiplied. So if you divide both sides of the equation by one of the brackets, you'd be left with x minus 8 equals 0. Therefore, to solve it, you'd add 8 on both sides. And that is why x would be 8. And that is why it's always going to be the inverse, because it's always equal to 0. And you're either going to have to do the inverse of addition to get it to the other side or the inverse of subtraction. But the shortcut is it's the inverse of whatever is in your brackets. Okay, so expanding double brackets is something we need to be super confident with. So there's the quick way, which is just putting a little dot above the first term in the first bracket and multiplying it by each term in the second bracket. So x times x is x squared. X times -7 is -7x. 2 times x is 2x, and 2 times -7 is -14. Then we collect the like terms. So -7 plus 2, remember the sign, like the negative or the positive sign always belongs to the term after it, so we circle the whole thing. So -7 plus 2 is -5. So you'd be left with x squared minus 5x minus 14. Then it gets a little bit trickier because you've got a coefficient of x, but we do the same thing. 3x times by 2x, and if you need to, you can just do working on the side just to help remind you. You do 3 times 2, which is 6, and x times x is x squared. So we'd get 6x squared, and then 3x times by -3 is going to be -9x, minus 2 times 2x is going to be -4x, and -2 times -3 is going to give you +6. So remember, a negative times by negative gives you a positive. So then, once again, we simplify and collect the like terms. 6x squared minus 9 minus 4 is going to be -13x, and then 6. So there are our answers over there. So a very good way of thinking about expanding brackets in context is when we're working out an area, because you've got one term plus another term multiplied by 2 other terms. So over here, I'm told that the area of square ABCD is 20 centimeters squared. So I know that this square is going to be whatever the length of one side is multiplied by the other is going to be 20. Now, the key piece of information is that it is a square, which means that both sides have to be equal. So if my first side is x plus 4, then that must mean that this side is also x plus 4. So this length here would be 4 centimeters. Now there are a few ways you could do this. You could either show it as an algebraic bracket, okay, or you could think to yourself, okay, well, how can I actually work out the area? 4 times 4 is 16, 4 times x is 4x, 4 times x is 4x, and x times x is x squared. So this visually shows you what happens when you're expanding brackets, but you could also algebraically show it. So if we did that, we'd say x times x is x squared, x times 4 is 4x, 4 times x is 4x, and 4 times 4 is 16. So we'd end up with the same thing, just shown algebraically. The next thing we would do is simplify that. So I know that the area of the square is 4x squared plus 8x plus 16 must equal to the area. Now I know that the area is 20 centimeters squared, so I'd say that x squared plus 8x plus 16 must equal 20. And then what could I do? Well, I need to show that x squared plus 8x equals 4, so let's just rearrange it. Let's subtract 16 from both sides, and you've shown that x squared plus 8x equals 4. Okay, so when I'm factorising, what that means is I'm looking for the highest common factor of the both terms, and I want to pull that out. So if you imagine it's like an orange juice and you're trying to squeeze as much out of the orange as you possibly can, that's what we're doing when we're factorising. We're trying to squeeze every single possible factor out of the bracket and put it on the outside. So what's common to 4x and 12? Well, I know that 4 is the highest common factor of 12. So I'm going to put that outside the bracket, and then 4 times x makes 4x, and 4 times 3 makes 12. So you pull out the highest common factor, and then you think to yourself, what would I multiply that by in order to get back to my term? Well, 4 times x is 4x, and 4 times 3 is 12. So factorising is literally the opposite, the inverse of expanding brackets. So you can always expand your bracket to double check if you got it right. But factorise means put brackets in. Okay, so next we've got 6x take away 3x squared. So sometimes it might be helpful if we actually write out what the factors are. So we know that 3 is the largest number. So what we might want to do is just write this as a factor of 3. So I could write 6 as 3 times 2 times by x, and I'm subtracting 3 times by x. So if you write it out like this, it just makes it easier to spot the common factors. You might already be super good at this, in which case don't worry, you stick to what you do, but this is just another way. So I know that 3 is the largest numerical factor, and then I've also got an x in common, so I can pull out 3x. And then what am I left with? Well, over here I'm left with 2, and then over here I'm just left with x. You can double check it. 3x times 2 is 6x, and 3x times by minus x is minus 3x squared. You might just want to write, if you are doing a double check, just write that you are double checking so that the examiner knows that this is your final answer. I'm just showing that you can double check it just so that you feel safe in the exam. And then we're being asked to factorise fully, the next step. So again, I can write it out so that each little step is being done in its factors. So let's write 8 as a factor of 4. I could write that as 4 times 2. X squared means x times x, and y is just by itself. And then I've got 4 times by x times by y times by y. So let's pull out the common factors. You've got 4 is the highest numerical factor. Then you've got an x in common, and then you've got a y in common. So 4xy is going to go on the outside, and then you're going to be left with, over here, 2x plus y. Double check, so 4xy times by 2x is going to give you the same thing, and my screen's gone funny, so I'm not going to do that, but that is what we do. Okay, so factorising quadratics, every quadratic can be written in the form ax squared plus bx plus c. And all that means is that a is the coefficient of x squared, b is the coefficient of x, and c is the number that's on its own. So you're always looking for two factors that times to make c, and add or subtract to make b. So you start by writing out the factors of 12. You've got 12 times 1, 6 times 2, and 3 times 4. And which of these two also add or subtract to make 8? Well, 6 plus 2 gives me 8. So to factorise that, it's going to be x plus 6, x plus 2. Let's try the same for the next one. So I'm looking for the factors of negative 27. So you've got 27 times 1 and 3 times 9. One of them is going to have to be a negative, because the only way you can make a negative is by multiplying a negative times by a positive. And they also need to add or subtract to make minus 6. So if I think to myself, it's most likely going to be these three. And if I had minus 9 plus 3, that gives me minus 6. If I had minus 3 plus 9, that gives me positive 6. So I know that I'm going to go with this option. So in my brackets, I've got x minus 9 and x plus 3. So you've got solving inequalities, and it's exactly the same as when we're solving an equation. It's just instead of an equal sign, there's a less than or greater than or less than or equal to. So over here, I'm going to do exactly what I would if this looked like this. I'm just going to keep this sign like that instead of an equal sign. So what would I do first of all? And over here, well, I would subtract x from both sides, because when you have a variable on both sides, you subtract the smallest one. So if I subtracted x from both sides, I would be left with I'm subtracting. So I'd be left with 2x plus 4 is less than or equal to minus 7. What would I do next? Well, I would take 4 from both sides. So 2x is less than or equal to minus 11. And then the final part would be I divide by 2. So x is less than or equal to minus 11 all over 2, or you could say x is less than or equal to minus 5.5. Hasn't specified, so it doesn't matter, you can leave it in fraction form. Now the next one is a little bit trickier because you've got double-sided inequality, and all you have to do is just take it step by step, and whatever you do to one side, you have to do to like all sides. So because now there's 3 sides, you do it to all 3 sides. So the first thing I would do, if it was a normal equation, if it was like minus 2 equals x over 3 plus 2, is I would subtract 2. So let's start by doing that to each part of the equation. So minus 2 is minus 4, is less than or equal to x over 3, which is less than 5. Next step, what would I do if it was a normal equation? I would times both sides by 3. So now I just have to multiply all sides by 3. So that'd be minus 12 is less than or equal to x, which is less than 15. And then you've solved it. You've got x in the middle and you've got integers on either side. So thanks very much for watching that video. If you found it helpful, then just hit a like, press subscribe, or maybe tell your friends if you think that they would benefit from this too.